this is a chapter 6 review for 6.1 to 6.4. Number 1, you're going to see if the given graph is a decay or growth. The given graph, that is the purple graph, is falling from left to right, so this is going to be a decay graph. To find the number for the decay graph is to find this point right here, -1, 4. Actually it is 1, b, so you have to find it from this point, but b is not very clear. It is clear on the other hand instead. So -1, 4, you just write 4 as 1/4 to get the parent function for this purple graph. Now you need to see what is the translation from the purple graph to the blue graph. The center point is this one, so from here to here, how would you reach is you go 1, 2 down and 1, 2, 3 left. So 3 left and 2 down is your translation. How you write as a function, so this is a function for the blue graph, that is, you can call it as gx. For the left, you're going to say +3 here, and for down, you're going to say -2 on the side. The asymptote line, which was y = 0, went 2 units down, and that is y = -2. Similarly, for number 2, this is going to be a growth graph because it's rising from left to right. And we're going to find out the actual graph function, which is 1, b, and the b in this case is 2. If it is a rising graph or a growth graph, you take the b as it is, that is 2. So the parent function becomes 2 to the power x. Now from this point to this point, you just see its path. The path from this point to this point is going to go up 2 unit and left 1. So from here to here, you're going to see is up 2 over 1, up to 1 left. So writing up 2 means that +2 outside. Writing left mean right next to x you're going to have +1. And that is your gx graph, that is your translated graph. Your asymptote line is also moved 2 units up. So it was y = 0 and it's moved 2 units up, that is y = 2. For number 3, it's going to go from rising from left to right. And this is going to be a growth function. So this is a growth function. To find out the point, you're going to find out what is the value of y when x is 1. So that's going to be 5. It means the parent function is 5 to the power x. What is the transformation? You look at how high it goes on here. So the transformation, you're going to count. If you pick up the center point, then go to the center point. What is the path you're going to follow? So you're going to go 1, 2, 2 up, and 1, 2, 3, 4 right. So 2 up and 4 right, 2 up and 4 units right. And if you want to write it in a function form, you're going to write down is 5 to the power x minus 4 plus 2, and that is your translated graph. And the asymptote for this one is moved 2 unit up, so the asymptote is going to be y = 2. So for number 4 is a falling graph, so it is going to be a decay graph. To find the parent function, you find what is the value of this point when x is -1. When x is -1, what should be the y value? That is 3. Since it's a decay, so it should be 1/3, because b, which is base 1/3, should be less than 1. The transformation from purple to blue graph, if you go from middle point to middle point, see what is the path you follow. So 1, 2, 3, 4, 5 up. So it's going to be 5 unit up, comma, how many unit left or right? So it's going to be 1, 2, 3, 4, 5 unit up and 1, 2, 3 unit left. So this is going to be 3 left. To write the function, you just rewrite 1/3 x plus 3 on the top, and plus 5 for up 5 unit. You can also work on to find out how many unit up this asymptote line moved. So this is 1, 2, 3, 4. So 4 unit up. So for 5 and 6, you're going to use the given information to write the growth rate equation. The growth formula is y equals a 1 plus r to the power t. Then you're going to find the amount in the account after given year. So plug in the value that is for t, for years. For number 5, Emily opened a college saving account with how much money? That is the principal amount, or the initial amount is 11,000 in 2020. The average interest rate for this is R equals 2.5%. So if it's R equals 2.5%, you're going to turn that into decimal. That is going to be 0.025. So that is the R value you're going to use. How much did the account have at the end of 2024? So it means that in this case the T is, so the T is time in years. So from 2020 to 2024, the difference is T, that is 5. Now you're going to plug it in everything, plug these values, everything into the given formula that is right there on the top, and find the equation. So the equation is y equals initial amount 11,000, 1 plus initial amount is 11,000, 1 plus 0.025 to the power 4. So you're going to solve the inside of the parentheses and then take an exponent and then multiply it by 11,000. So you're going to here is 11,000, 1.025 to the power 4. So I'm going to do this in the calculator in one stroke. So I'm going to first put the 1.025 and this for the exponent, and then press 4. Whatever I get, I'm going to multiply this by, so multiply by 11,000. And then what you're going to get here is 12,141. So 12,141.94. And that's the final amount after 4 years at the rate of 2.5%. So you're going to do the number 6 same way, where A is going to be 8,700, R is going to be 0.038 because you change it into decimal, t is going to be 5 years. And when you do this problem, again you're going to just use the calculator. To the power 5, 8700 to the power 5. So you solve this through the exponent. So 1.038 power 5 times 8700. When I did the calculation, 1.038 to the power 5, and I multiplied the answer by 8700, the final amount I got was 10,483.49. So 49, or you can also say 50 cent or 49 cent. Anyway, it is going to be the right answer. So for number 7 is going to be a logarithmic function, graphing logarithmic function. So first of all, you're going to change the logarithmic function into your parent function of exponential function. So this is log 4x plus 3. But if you want to find the parent function for this one, is the log 4x. So log 4x is the parent function. It means that you change that into the exponential function, which will give you 4 to the power x. And this is going to be the parent function, log 4x. After that, we are going to deal with this plus 3 and negative 1. So just find the parent function first of all and turn that into exponential, and then deal with the transformations. So just make sure that first you turn this logarithm and understand its parent function. The parent function for this one was log 4x. You change that into exponential form. So this is an exponential form. Once you change that to exponential form, then you switch the x and y and graph. After you graph, then you deal with the transformations. You're going to use only 3 points, as we already know that 3 points are enough to get the good looking graph, and those ones are -1, 0, and 1. That's what I'm going to use. 4 to the power -1 is 1 over 4. 4 to the power 0 is 1, and 4 to the power 1 is 4. This is going to be your y value when you plug in the top x values into this x. Now you're going to switch, so this becomes x and x becomes y. So you're going to get what is y, here is x. Just remember that 1 over 4 is 0.25. It's helpful if you understand this part in terms of graphing. And for the x value that is switched to y is -0, -1, 0, and 1. Now you're going to graph this. So you're going to graph this onto the this graph paper. Transformation. So what is a transformation which goes at the end is 3 left and 1 down. Let's graph the parent function. So this is parent function. So let's graph parent function first of all. When x is 1 over 4, y is -1. So this is the point right here. X is 0.25, y is -1, 1, 0, 4, 1. You graph this. You graph this logarithmic function. where your asymptote this time is this line, which is x equals 0. How we change now as a transformed function, you're going to move this graph 3 units left and 1 unit down. You're going to move each point 3 units left and 1 down. So when you talk about this point, 1, 2, 3, 1 down. So this is going to be the point. So 1, 2, 3, and 1 down. 1, 2, 3, 1. 1, 2, 3, 1 down. 1, 2, 3, 1 down. So I'm going to take out the extras, but this is going to be my graph, that is the transformed graph when you translated the parent graph 3 units left and 1 unit down. Also, the asymptote line is moved also 3 units left, so it means x equals -3 is now your new asymptote line. Okay. For number 8, I'm going to just write down the parent function for the log. So parent function for the log is log 3x without the translation. You change this to exponential function. So exponential parent function becomes 3 to the power x. Once you find 3 to the power x, you're going to find out the log 3 to the power log 3 of x. Okay, these are the table values I got for 3 to the power x, and then I switched the x and y, and these are the table values I got for log 3 of x. So for the translation, you're going to move this to 4 unit right and 5 unit up. The parent graph for log 3x is follow this table. So follow this table and graph it here. And for the translated graph, you're going to move 4 unit right and 5 unit up. So that's going to look like 1, 2, 3, 4 right, 1, 2, 3, 4, 5 up. So this is going to be your new graph. And similarly, you're going to follow all the points and move all of them to up 5 and 4 right. And that's going to be your new graph. For the translation, 4 unit to the right and 5 unit up.